Newton's laws of motion fundamentally rely on one concept, that there's absolute space and absolute time. What this means is that everyone agrees on the absolute positions of objects, and also everyone agrees on what time something happens. One way of thinking about absolute space and time is to imagine that everything, the whole universe, is a room with fixed walls, so that everything happens in this room. We can all agree on the position of an object in this room because the walls of the room are fixed, and we can all measure the position of an object with reference to a fixed point of the room. And we can also all agree on what time it is because there is a universal clock fixed to a wall, and we can all see the same time. These ideas of absolute space and time seemed perfectly reasonable in Newton's day because there was no evidence to the contrary, and these ideas fitted well with what could be observed and measured. We now know, of course, that Einstein came along at the start of the 20th century and changed the ideas about space and time in his theories of relativity, and we will come on to those in later videos. Relativity is the fullest picture we have of space and time. So we could use relativity even for simple motions on Earth, like throwing a ball or an apple dropping from a tree, but it would be unnecessarily complicated. Newton's laws are a subset of relativity theory, where we can use Newton's laws as long as we are not moving close to the speed of light and we are not close to large gravitational forces like with black holes. So using Newton's laws of motion are perfectly good enough for all practical purposes on Earth and in the solar system, because the differences between Newton's laws and relativity are insignificant in these cases, and usually not even measurable. So for now, when we look at Newton's laws, we will assume there is absolute space and time. I hope you found this video interesting. Until next time, keep thinking physics.